LiDAR stands for light detection and ranging, and is a remote sensing method similar to radar or sonar, but it uses light. It can sense how far away objects are from the sensor by using a laser to send out beams of light. I chose this topic because recently an ancient mine site was found underneath an overgrown Guatemalan jungle using aerial LiDAR. It was a vast web of interconnected cities that housed millions of people. It was hidden for so long because the jungle grew around it and kept it from view, but using aerial LiDAR mapping, we were able to uncover it. There are three main ways to use LiDAR: from the air, from a satellite in space, and from the ground. The most widely used source is from the air, so I'll focus on that. For aerial LiDAR, the most common application is measuring elevation and creating topographical maps. It can be very complicated to record accurate data from an airplane. The type of light that is used is very important because some types of light reflect better than others off of certain objects. Most planes use green or near-infrared light because it reflects easily off of vegetation. Planes must also use an inertial measurement unit, or IMU, that takes into account the plane's altitude, tilt, rotation, GPS location, turbulence, acceleration, velocity, etc. As you can see, a lot of different variables can be a factor in determining height. You need this because when you're calculating height, you need to know the location and relative motion of the sensor so your analysis can be accurate. To calculate height, light is sent towards the ground, and this light gets reflected back. The LiDAR unit scans the ground from side to side, so it can cover a wide range of terrain. The outgoing light is called the pulse, and the light that gets reflected back and recorded by the sensor is called the return. The sensor emits an electrical signal if the pulse is received, and this information is recorded on a computer. Most light emitted from the plane is at an angle, which is called off nadir, while the light emitted perpendicular to the ground is called nadir. Light that travels off nadir will have to travel a greater distance than the light that travels nadir. The inertial measurement unit keeps track of all this information and stores it into the computer for later analysis. In the physical calculation of height, the computer in the LiDAR system records the time it takes for the light to travel there and back. It then plugs it into this equation where c is the speed of light, time is the time between the pulse and the return, and it is divided by 2 because the light has to make 2 trips there and back. This distance is subtracted from the plane's altitude to get the elevation of whatever the light hits. The computer also has to incorporate all of the information that the inertial measurement unit recorded about the plane's motion into the final calculation. Realistically, light does not completely reflect off of one object, but instead some gets reflected and some goes through and reflects off something else. In these cases, there would be several returns for each beam of light. Having several returns can be indicative of what is there, such as trees or shrubs. If the pulse is identical to the return, then we know that the light bounced off the ground. If the pulse has several returns, we can interpret the last return to be the ground. Aerial LiDAR does not have to be restricted to land. You can also use LiDAR to map out oceans. However, it is much more difficult and expensive. This process is called bathymetric LiDAR. Bathymetric LiDAR is much more difficult because when light travels through water, it bends, refracts, and slows down much more than when it travels through the atmosphere. So the computer records all the measurements from the inertial measurement unit and accumulates all this data, but now it needs to turn it into something meaningful. First, it takes all the pulses and returns and creates something called point cloud data. Essentially, it three-dimensionally draws a point at the calculated height at a certain point in space. It does this for every single data point and puts it all together into a 3D model. This helps to visually show what was scanned. Usually different colors represent different heights, and it makes it easier to interpret the data. As you can see in this picture, the more pulses you have, the more accurate your data will be. LiDAR can have many applications, and it is being used for more and more purposes. Like I said in the beginning, there was a massive discovery relating to ancient Mayan cities. LiDAR can also be used to make self-driving cars by making 3D models of its environment and adjusting its course accordingly. LiDAR can make models of areas that are at risk for floods and improve planning of structures. These are only a few examples of what LiDAR is doing today, and these are the works cited.